Acute angles and right triangles for plane and spherical trigonometry. This will be our second main topic. Now, at the end of this session, you guys are expected to, one, know the trigonometric functions of acute angles. Next, understand the trigonometric functions of non-acute angles. Next, be able to provide approximations of trigonometric function values. And lastly, present the solutions and understand the applications of right triangles to real life problems. So we already have encountered this illustration, right? That any angle is always measured from the positive x-axis, and once that angle is measured from the positive x, where its vertex is at the origin, that angle is in standard position. So if we have a certain point here, the the distance from the vertex to the point, from this point to here, we call it the R, right? And if we draw a line perpendicular to X that passes through point B, we create a right angle here represented by a box. We call that our Y, right? And this is our X. And to solve for our R, we'll use the distance formula, which we have derived. Now, angles in standard position can be used to define trigonometric functions. There is also another way to approach this, and that is in terms of ratios of the lengths of the sides of a right triangle. Since we have created a line that passes through point B and it bisects the x-axis, we have created a right triangle, right? This side here is y, the lower at the side of the triangle that lie in the x-axis is call that x, and the hypotenuse of our triangle we call that as our r. The figure on the right shows an acute angle A in standard position. The definitions of trigonometric function values of A require x, y, and r. And as drawn in the figure, x and y are the lengths of the two legs of the right triangle, and r is the length of the hypotenuse, which I said a while ago. So therefore, if this is our angle here, and we call that as our angle A, by definition, since sine of any angle is equal to y over r, and if you can observe, based on this triangle, y is opposite to our angle A, meaning nasa sa at bang sa atong A. So y is equivalent to the opposite side of the triangle divided by our r in terms of this triangle is base here is our hypotenuse. So our hypotenuse. And we know that by definition as well, cosine of any angle is equal to x over r, right? And our x here is tapad ni angle A. And tapad is adjacent side sa ato ang triangle, and r is still our hypotenuse. And it follows na dayon, tangent is y over x, so meaning opposite side divided by the adjacent side, and then its inverses, cosecant, secant, and cotangent. And to summarize all of that, right triangle-based definitions of trigonometric functions, and we let A represent any acute angle in standard position. So sine A is equal to, sine is y over r, right? So that is side opposite to A divided by the hypotenuse, which we have derived a while ago. And then cosine A is x over r. It is equal to the side adjacent to A divided by the hypotenuse. And tangent A is y over x, and y is side opposite to A, and x is side adjacent to A. Now, please note that sometimes we shorten the wording. Like instead of saying side opposite A, we just use side opposite, or uban gani, they will just use opposite. Opposite over hypotenuse. And knowing that, find sine, cosine, and let us do example one, sorry. Find the sine, cosine, and tangent values for angles A and B in the right triangle. So this is our A. We start with A. For A, so that is sine A is sine by definition, that is opposite to A divided by the hypotenuse. So that is 7 over 25. Cosine A is equal to adjacent over hypotenuse. So this time the adjacent is 24. And still the hypotenuse is 25. For our tangent A, that is opposite over adjacent. So opposite to angle A is 7 and adjacent to A is 24. So that's 7 over 24. Next, for our letter B, let me delete this. Okay. For B, sine B, opposite to B. If this is B here, opposite to B is 24. And hypotenuse is still 25 because the hypotenuse is the longer side. So that's 24 over 25. And then cosine B is equal to adjacent. Adjacent to B is this one. That's 7 over 25. And then tangent B is 24 over 7. So if you can observe, base ani. So, but before that, there you have it, mauni ang sine, cosine, tangent values for our angles A and B in a right triangle. But what I said a while ago when I say na natay makita nga similarity, and that is this one. Sine A, which is 7 over 25, while cosine B is also 7 over 25. Sine B is 24 over 25, while cosine A is 24 over 25. And that will be our next topic.